In the next part of our lesson, we'll be talking about the possible values of a random variable. Now, what is a random variable? In our last meeting, we talked of it as any variable. It can be discrete, it can be continuous, it can be any variable, and we assign a possible value. Now, how do we do it? For example, let me go immediately to my tool, my snipping tool. Earl, you can see you. Now here, let me share my snipping tool. For example, this one. We are tossing 3 coins. So that's 2 times 2 times 2. There are 8 possible outcomes. And let X be the random variable representing the number of heads. So what's the first thing to do? The first thing to do is to record the possible outcomes. Example, head, head, head. Next, head, head, tail. Actually, you can make a tree diagram to be accurate with this one. Head, tail, head, head, tail, tail. Tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. Be sure that no outcome is duplicating, or else if you'll get wrong in this first table, you'll have a problem because the next data or the next outputs that you'll have will all be wrong. So you need to be very careful in listing your possible outcomes. Now, let's count. How many heads are there? In the first one, there are 3. In the second, 2. In the next 2. In the next 1, 2, 1, 1, and 0. You look at the second column. What are the possible values of your random variable X? Then it can be 0, 1, 2, or 3. So this is now our first output. Our next output is we need to make the PMF. What's the PMF? The PMF is called the probability mass function. It can be written in a table and it can be written in a piecewise function. It shows us the probability distribution. How is the data being distributed based on their probability values? So how does it look like? Now, I want you to check on this data because we will be using it in the next part. I will just draw a table here for you to clearly see it. That will be X, and the other is P of X. Remember, there are 8 possible outcomes. Now, what are the values of X that we have? We have 0, 1, 2, and 3. If we talk about probability, we talk about chances. What's the chance that that value will occur? Now, if you look at the second column, how many times did we see 0? We just see it once out of 8 outcomes. So the probability is 1 over 8 or 1 out of 8. Ma'am, can I write it in a decimal? No problem. But I prefer to have it in fraction because it's more accurate, especially if it's a non-repeating, non-terminating decimal. I prefer the fraction. For 1, how many times? 3 out of 8. The other for 2, 3 out of 8. And for 3, it occurs 1 out of 8. Now, there are properties to be considered. First, the value of p of x lies between 0 to 1. If it's certain that it will not happen, the probability is 0. If it's certain that it will really happen, the probability is 1. But majority, it's between these values. It can never be negative, and it can never be more than 1. Another characteristic is if you add the summation of the p of x column is 1. If you check 1 plus 3, it's 4, plus 3, 7, plus 1, that is 8 over 8. How do we write this in a piecewise function? We say p of x equals, it can be 1/8 or 3/8. When is it 1/8? If x is equal to 0 or 3. When is it 3/8? If x is equal to 1 or 2. Then the last part of this lesson is to draw a histogram. In the y coordinate is the p of x. 1/8 and 3/8. In the x-axis, we have the values of our random variable. So 0, 1, 2, 3. Now, how is a histogram different from a bar graph? In the bar graph, you write the numbers in this marker. But in the histogram, you write the number in the space. Second, in the histogram, there's no space between bars. It goes next to each other. While in the bar graph, like in the bar graph, you see it this way. This and another stack and another stack. But in the histogram, you see it this way. Like that. So let's start with this one. For 0, the probability is there, 1/8. For 1, that's 3/8. For 2, that's 3/8. For 3, that's 1/8. And you can shade it if you want. So that's the end for our first example.